Dear students, in this class, let us discuss about the real line, its epsilon neighborhood, and so on. So actually, what is a real line? The familiar and convenient geometric interpretation of the real number system is nothing but a real line. Means, suppose R is the set of all reals. Then the real number system is R union set of minus infinity, infinity. So this is the real number system. R union set to minus infinity. Sorry, R union is minus infinity, infinity. Okay. Means, so it is more conveniently we can represent geometrically it as in this way. It is minus infinity to infinity. So minus infinity and infinity are not real numbers, they are merely symbols. They are only symbols. So this is the geometrical interpretation of the real number system, and this is known as a real line. Means the familiar and convenient geometric interpretation of this real number system is nothing but the real line. This is the real line. And minus infinity and plus infinity are only merely or only the symbols. So this is the real number, the geometrical representation of the real number system is the real line. Okay. Now let us consider what is an epsilon neighborhood. Epsilon neighborhood. What is epsilon? It is epsilon is always treated as a positive point, sufficiently small positive. And what is modulus of A? Mod A, the absolute value of A. We already defined it as mod A equals A if A greater than 0, minus A if it is negative, and 0 if A equals 0. Okay. Actually, this modulus of A, that is the distance of that A means, modulus of A means the distance of that point A from the origin. Distance of that point A from the origin is referred as modulus of distance of. That's always taken as positive. Okay. Distance is always taken as positive. Now consider. Let A is any real number. A is any real number. Epsilon is positive. Then the epsilon neighborhood. The epsilon neighborhood of A. Epsilon neighborhood of A is denoted as this way. It is rated as V epsilon A. This is the epsilon neighborhood of A. So, consider the real line. Suppose A is, here it is, epsilon is positive, therefore A minus epsilon should less than A, and A plus epsilon should greater than A. So, this is A minus epsilon and A plus epsilon. So, this epsilon neighborhood of A is defined as it is a set of all x of all in R such that modulus of x minus A strictly less than epsilon. This modulus of x minus A, what is modulus of x minus A? Modulus of x minus A is also taken as d of x and A. There is distance between x and A. You can replace it as d of x and A less than epsilon, whatever may be. Okay. So set of all x of all in R such that modulus of x minus A less than epsilon. That means it is set of all x of all in R such that minus epsilon less than x minus A less than epsilon. Sure. Equals set of all x of all in R such that A minus epsilon less than x less than A plus epsilon. A minus epsilon less than x less than A plus epsilon means this x of all in where it is, A minus epsilon less than x less than A plus epsilon means, okay, this x of all in where open interval A minus epsilon and A plus epsilon. So this is the open interval A minus epsilon and A plus epsilon. So this is known as the epsilon neighborhood of E. So this is simply V epsilon of A is nothing but open interval A minus epsilon and A plus epsilon. Okay, so this is the epsilon neighborhood of A. This is epsilon neighborhood. This open interval, A minus epsilon and A minus epsilon. So actually, what about the V epsilon neighborhood of 2? V epsilon neighborhood of 2, according to this argument, it is open interval 2 minus epsilon and 2 plus epsilon. Okay, why? Because V epsilon A is this one. If epsilon is half, suppose epsilon is half, then what is the half neighborhood of 2? V epsilon neighborhood of A is V epsilon of A. So the half neighborhood of 2 is nothing but open interval 2 minus 1 by 2 and 2 plus 1 by 2. That is 2 minus 1 by 2 means it is open interval 3 by 2 and 5 by 2. So means on the number line, if it is 2, so it is then the 1 by 2 neighborhood of 2. The 1 by 2 neighborhood of 2 is, suppose this is 2 and here it is 1, here it is 0. Okay, then it is 3 by 2. 3 by 2 means 1.5. So here it is. Suppose this is 1, so this is 1.5. So this is 3 by 2 and it is 5 by 2. Okay, so this is the 1 by 2 neighborhood of 2. So this is a crucial point. The epsilon neighborhood of A, which is defined as set of all x fall in R such that the distance between x and A or modulus of x minus A strictly less than epsilon. So the epsilon neighborhood of A is nothing but the open interval A minus epsilon and the A plus epsilon. Okay. So if x fall in V epsilon E, if x fall in V epsilon, where A is positive and for all epsilon is positive, x fall in V epsilon A. X fall in V epsilon A means, listen, x fall in V epsilon A, x fall in V epsilon A for all epsilon is positive and epsilon is positive. So that means x fall in V epsilon A means it is a modulus of x minus A strictly less than epsilon. Set of all x fall in R such that modulus of x minus A less than epsilon. Epsilon is a sufficiently small positive quantity. Modulus of x minus A less than epsilon means x goes to A. Okay, x goes to A. So moreover, we can say that x equals A. Clear? Now, suppose x be the, x and y be the epsilon, suppose x and y be the epsilon neighborhood of A and B respectively. X be the epsilon neighborhood of A, x be the epsilon neighborhood of A, and y be the epsilon neighborhood of B. Then what about the neighborhood of this A plus B? It is need not be epsilon. By x be the epsilon neighborhood of A means, x be the epsilon neighborhood of A means the epsilon neighborhood of A. What is epsilon neighborhood of A? B epsilon E. That is set of all x fall in R such that modulus of x minus A less than epsilon. So x be the epsilon neighborhood of A means, x be the epsilon neighborhood of A means modulus of x minus A less than epsilon. Okay. Y be the epsilon neighborhood of B means modulus of y minus B also less than epsilon. X be the epsilon neighborhood of A means modulus of x minus A less than epsilon, and y be the epsilon neighborhood of B means modulus of y minus B strictly less than epsilon. Then we can consider what about the modulus of x plus y minus of A plus B. Consider this one. Consider modulus of x plus y minus of A plus B. So by triangle inequality, or this equals modulus of x minus A plus y minus B. Modulus of x plus y minus A minus B. Modulus of x minus A plus y plus B. by triangle inequality, it is mod x minus a plus mod y minus b. But mod x minus a less than epsilon. So it is strictly less than epsilon plus epsilon means 2 epsilon. So modulus of x plus y minus of a plus b is strictly less than 2 epsilon. So that means this x plus y should belongs to the 2 epsilon neighborhood of a plus b. 2 epsilon neighborhood of a plus b. So listen, means we can conclude this in this way. That is, if x fall in v epsilon a and y fall in v epsilon b, means if x be the epsilon neighborhood of a and y be the epsilon neighborhood of b, then x plus y always lies in 2 epsilon neighborhood of a plus b. Okay, this x plus y need not be lies in epsilon neighborhood of a plus b. When x lies in epsilon neighborhood of a and y lies in epsilon neighborhood of b, then their sum, the x plus y should lies in where 2 epsilon neighborhood of a plus b. It need not be lies in epsilon neighborhood of a plus b. Okay. Right. Now let us discuss about the important properties of real numbers. Means it is the completeness property. That property is known as completeness property. Completeness property of real numbers. So this is an important property. Completeness property is an important property of R. So listen. First we discuss about the boundedness of R. What is bounded? Means, consider S. Suppose let R be the set of reals. S be the non-empty subset of the completeness property of R.